So obviously the starting point of any good calculus course is algebra, and I'm now just going to blow your mind. Woohoo! There we go. Like terms can be added or subtracted, unlike terms cannot. A simple idea. Basically, if you don't know what it is, how on earth can you add something else that you don't know what it is? What's an x, what's a y, how can I add them? Don't know. But if I've got two x's, I might not know what they are, but I know I've got two of them, two x's. I don't think I bothered with an example for that one. I think we should at this stage be coping okay with it. The index laws. You will recall that when we multiply, we add the indices. When we divide, we subtract the indices. When we have that parentheses situation, that's when we multiply. And then, of course, the lie that we continually tell you, which is anything to the power of 0 is equal to 1. And, of course, it's not true. But anyway, well, no, of course it's not true. Remember, all you need to do is give me a counterexample where it doesn't work, and then bang, it doesn't work. It's wrong. And I think I heard someone say it. What was it? A equals 0. 0 to the power of 0 is not 1. Put it in your calculator, see what happens. If you've never tried it. Error. Because we can't cope with that little question. Because 0 to the power of anything we say is 0. Right? But anything to the power of 0 is 1. So what happens when we go 0 to the power of 0? The maths just falls apart and it doesn't work. 0 is just this weird number that weird things happen with. Possibly because some people say it's not even a number. Because all it is a symbol representing the lack of value. But anyway, other than 0, of course, anything to the power of 0 is equal to 1. But what do these indices actually mean? Okay, if it's a positive, then I know it goes on the top of the fraction. If it's a negative power, I know it goes to the bottom of the fraction. It's probably more correct to say it goes to the other side of the fraction, because if you had a negative indice on the bottom of the fraction, then you could make it positive and put it on the top of the fraction. So it's probably more appropriate to say top of the fraction, same side, bottom of the fraction, the other side. Of course, we've been lying to you all these years. We keep doing it, and that's what we do in maths. Because originally, you remember, well, indices, they were just whole numbers, and they were positive. And we could simply say to you, oh, well, it's just how many times you multiply the number by itself. And it was very simple. But then, of course, we introduced negative indices. And, well, hang on, you're going to multiply it by itself negative 2 times? That doesn't make sense. And so there was, oh, no, well, that just means it's on the bottom of the fraction. Oh, okay. And then we got to fractions. So like power of a half. Oh, I'm going to multiply it by itself a half a time? Again, it doesn't make sense. What does it actually mean? In the fraction, the top tells you the power, or exponent if you want a fancy word, whereas the bottom tells you the root. So x to the power of a on b is the bth root of x to the power of a. Or, it depends which way you want to do it, you could say it's the bth root of x all to the power of a. I mean, they're equivalent statements. Which way do you write it? It all depends. If it's algebra, I usually use the first one. If it's numbers, I usually use the second one, because to find the root first gets it to a smaller number and then raise it to a power, rather than raise it to the power first, getting a bigger number and then trying to find the root. So that's the way I tend to. If it's algebra, I'll use the first one. If it's a number, I'll use the second one. Okay, so again, not mind-blowing examples, but just to illustrate the point. X to the negative 3, oh, hang on, that means the x cube's on the bottom of the fraction. The negative was the instruction. We've done the instruction, so it's gone. 1 on x to the power of 3. A to the power of 5, b to the power of minus 7. Okay, the 5's on the top, the 7's on the bottom. And then, as we like to do in maths, you remember, we'll go back to year 8 or whatever, and we go, let's try and make these look hard by throwing lots of them in. But you just do it step by step. And 3/4, they've given us the answer already, so that's nice. That goes 3 on the top, 4 on the bottom. X to the 4's on the bottom, a to the 9's on the top, and b squared's on the bottom. Power of a quarter. So that's telling me it's the 4th root of x to the power of 1. 2/3, the cube root of y squared. 3 on 2. Well, a mere mortal would leave the answer like that, the square root of x cubed. But of course, super mathematicians would write it like this. Well, we probably wouldn't write this line, but remember the idea of simplifying surds? You're breaking it up into two factors. One of those factors is a perfect square. Well, we can do that with x cubed. It's x squared times x. X squared's a perfect square. The square root of x is, square root of x squared is x. Actually, it's the absolute value of x, but let's not go there right now. And we get x roots x. There's an easier way. 3 on 2. I see 3 on 2. I think 1.5. You never write to the power of 1.5. It's horrible, it's awful, terrible notation. Don't do it. But when you think it, it tells you how to simplify the surd, because it's telling you it's x to the power of 1 times x to the power of 1/2. So you get x root x. So if I get something like that, which looks incredibly difficult, all I've got to do is I think 27 on 4 is the same as 4's in the 27. Was it 6 3/4? So I've got m to the power of 6 times m to the power of 3/4. Well, m to the power of 3/4 would be the 4th root of m cubed. Bang, done it in one hit. And of course we try to make it look harder. Oh my goodness. All right, let's work it out. First thing I will do is draw. What have I drawn? Oh, don't say line, someone said it. A vinculum. I have drawn a vinculum. Oh, some people's minds have just been blown. Okay. Right. The 2 goes to the bottom, the 1 goes to the top, but I know I'm going to put some pronumerals there, and we don't normally write 1x and 1, so the n goes to the bottom, the p goes to the top, the q goes to the bottom, but hang on, it's 1 on 28, so it's the 28th root of q. C goes to the top, 7 and a 6, but that is 1 and 1/6, so that would be c times the 6th root of c. And we finish off with r going to the top, and there it is. What once upon a time looked like a horrendous question is very, very simple. When you've got a fraction to a negative power, bang, just turn the fraction upside down. So it's 3 on 2 squared. That's the easiest way of doing it. 9 on 4. All right, so a handful of questions.